Today's quiz is a physics classic. If we have a ring and a ball, this ring is manufactured so that the ball will barely fit through, just barely. I don't know if you can even see any light going through there. The question is usually, if this ball were heated up with a Bunsen burner or something like that, would it still go through the ring? Most of us understand that it wouldn't. Molecules expand. What I have here is a molecular model that I've welded together with springs that simulates molecules. And you can see as I were to add heat, this will jiggle more and more and more. And what's going to happen is that each one of the molecules, or atoms we could say, is going to end up expanding their range in all directions. In other words, when we heat up this ball, it's going to expand. It won't fit through the ring anymore. That's been done many times. The problem that we're asking about today is, what if we just heat the ring? So the ring is going to get heated. We'll leave the ball alone. What happens then? Will the ball still go through the ring? That's our quiz. I'll hold it up now for the camera. As always, try to explain as much as you can about what's going on in this situation. And if you make diagrams, that'll also help explicate your ideas. The most typical answer that we get from students is that as we heat the ring, the metal, of course, is going to also expand, just like what happened with the ball. In this case, the metal is going to expand in all directions, just like with the ball, and it's going to end up sealing up or making this hole smaller so that the ball would not go through. A few will say that, well, it's going to be about the same as it was before. And some, very few, will say that, no, it's actually going to create a bigger gap. So those are the typical student responses that we get. Let's go ahead and heat up the ring and see what happens. Got my Bunsen burner, and I'll just start heating the ring. It'll take some time. That ring is very, very hot at this point. What we find is that the ball actually goes through even easier than it did before. In fact, you can already start to see little bits of light penetrating from around the diameter or circumference of this ball as it goes through. So there's a bigger gap than there was before. Now this has been shown before. What hasn't been, I think, done very well is provide an explanation of why would the ring, the hole inside the ring, get bigger. That's what I hope to show you right now. To help us understand the ring, let's just think of the ring as being a full sheet of metal. This full sheet of metal can be thought of as having our molecules that are connected together, bound together. So as they end up having more energy, they end up jiggling more, they're going to end up taking up more space. Let's just take one sheet of it, one plane of it, and let's think about putting individual atoms along the plane here. Maybe I'll make a 5x5 grid. I'll do that on the board quickly. I might speed it up a little bit. All right, let's say that this is at some temperature, room temperature, and I'll just put a T right here for it. It's got a certain temperature, T. As I increase the heat, these atoms are going to end up taking more space. They're all going to push each other out. That's the only direction they can go. So I'm going to redraw this, except in an expanded version. So let me draw that now over here. All right, these individual dots are going to be essentially showing that as the temperature increases, our atoms take up more space and they'll expand. But we're talking about a ring. So I can end up trying to make a ring, and this is going to be some higher temperature T, the average motion of the molecules. Well, let's just take a little ring here. I'll just take from here to here, and we can cut a hole where the ring would be. And if we just had a hole here that we cut out in this sheet of metal, which we can presume is our sheet, the same sheet that we would have, we'll just make that into our square sheet of metal. Overall, the square sheet of metal is going to become larger, and it would never become this large. You'd have to heat this up way too much, it would liquefy. But just for illustration, we'll pretend that it's grown this much. Not perfect, but we can see what's going on. I'll take the same number of atoms that I did before to make a circle. So here I can go from here to here. And you can clearly see that the circle would get larger. If I wanted to make it a ring, I could just have a pair of cutters and cut some of that metal, and I could just kind of make it the full ring. That, as compared to when it's heated, that ring would be bigger now. Not perfectly to scale, but I think we get the idea. And that helps us visualize why the ring expands when it's heated. It really does seem as though it should expand towards the center. But the atoms are pressing on one another and they've got nowhere to go, so they go out. So that's one way to think of this. I'm going to take you back over now and show you that if I did have the ball and I heated the ball, it won't go through the ring. So let's go do that. All right, let's just make sure that this ring is cool enough and the ball is cool enough. At room temperature, I can grab them to start this off. Turn on my Bunsen burner. We will heat the ball this time. Again, we can see that the ball will go through the ring. I'll put it in here and I'll let this heat up. And again, the molecules are going to end up expanding faster and faster and faster. They're going to occupy more space. They're jiggling more and more and more. Now, in this particular case, we are not heating up the ring. We're just heating up the ball. We'll get it a little bit warmer, and we'll see if it gets any more difficult to send it through. This is probably not hot enough, but already I can see that that will not go through. It's literally stuck. But if I simply take the ball, cool it back down in water, get some of it off there, now you can see that it'll go right back through. So it's a really nice way to think about atoms and how they interact and bond together in a solid state. What I'd like to show you now is a real-world application of this. So I got to change, and I'll show you this in a minute. All right, we've come down to the shop to show you a real-world example of when you might use this. Parts behind me are a water pump that's being fixed on this car. The problem is we live in the Northeast and there's lots of rust. I wanted to take the housing off and replace the thermostat. There's a special kind of stud. You have thread on one side, thread on the other. This shiny part goes into the engine. It's not supposed to come out. This other part is exposed to the air and, unfortunately, the salt water, so it's rusted on here. I was trying to take this nut off, but instead it took the whole unit out. My goal is to try to get the nut off, even though it's rusted. And by the way, it doesn't look that rusted right now. I've already used a wire brush. I've been soaking it in penetrant oil, which a can of it's behind me. The problem is the nut is on so tight. The threads of the nut onto the bolt are so tight that the penetrating oil can't even get down there. Our strategy is to heat this nut up. As we heat the nut up, each one of the molecules that makes up the metal is going to end up bouncing around a little bit faster, and it's going to expand. It's going to take up a greater volume. In other words, it's going to grow. Hopefully some of that penetrating oil will work its way in between those threads, and then I can loosen it. Now, I'm also going to use these cleaner threads that are not exposed to the elements. I'll probably end up actually putting the nut down a little bit on the clean threads, then I can get some more penetrant oil and then take it back up. And you might be asking, why not just buy a new one? Unfortunately, little parts like this, you find that not even the dealer can find it on their computer. Sometimes you just have to make do. What I'll do is I'll take the camera a little bit closer so you can see what I'm doing. All right, we're going to try to put this into the vise and tighten it up. On the very bottom here, there's no threads. You could put a pair of vice grips or something like that on there. I'm going to tighten this rather tight. Now I'm going to start applying a flame to it. I'll get my wrench ready, and then hopefully I'll be able to break this loose. Normally I wouldn't use this side of the wrench, but in this case I have very limited on the gap that I have. So I'm going to turn this on, and I'm just going to end up heating the nut and not the bolt. So I'll take my time, I'll go around, I'll heat it evenly throughout. I can actually see a little bubbling of some of that penetrating oil that I had on before, starting to smoke. And I'm just going to put a little bit of heat on each side. Let that washer expand. Some of this penetrating oil could catch on fire, but there's a minimal amount of it. Just heating the nut, heating the nut. You got to be patient. I don't want to end up transferring heat to the bolt. If the bolt also expands, well, that's not going to help me. So I really just want the nut to heat up. As I heat it, those molecules end up expanding in their crystalline lattice. And we'll try this and see if it works. Tighten this as much as we can, and let's see if we can get it to move either way. And lo and behold, it's moving, and now I can get some penetrating oil on the bottom, and I should be in good shape. Now I can take this back the other way. So once you have it work loose, you're going to be able to get some oil in there. You're going to be able to clean everything off. So, all right, that's your quiz and your real world application.